This is for 4 permutations part 1. We're going to do this with an example. I'm going to create the entire sample space for this experiment, and then we're going to count them. And then I'm going to use the fundamental counting rule to count them. And then in the next video, I'm actually going to use the definition from the book. But let's just start out with the basic understanding of permutation. If you're asked the question, how many ways can you arrange the letters A, B, C, D, we would answer it by making the sample space and counting it, at least when the sample space is small. So I can either go A, B, A, C, A, D. I could go B, A, B, C, B, D. I can go C, A, C, B, C, D, and lastly I can go D, A, D, B, and DC. Now, very important, when it comes to permutation, order matters, all right? AB is different from BA, all right? A is first, B is second is different than B is first, A is second. If you care about first, second, and third place, then order matters. When order matters, you're using permutation. At any rate, if we look at our outcomes for the experiment, there are 12 different outcomes. There's 12 different ways that I can arrange A, B, C, and D where I care about the order. Now, if I'm using the fundamental counting rule, all right, there are 2 events. There's picking the first letter, and then there is picking the second letter, and very specifically, I'm not repeating anything. How many ways can I pick the first letter? Well, it's going to be one of these 4. So that's just going to be 4. Now when I pick the second letter, I've already used up one of the letters. So if I already used one of the letters, I can't use that one again because I'm not repeating. So I've used one of them, so instead of 4, I have 3. Multiply those together, 4 times 3 is equal to 12. And you can see that in that we have 4 columns and 3 rows, right? 4 times 3 is 12. Now, using the fundamental counting rule works wonderfully when it's small numbers, but we won't always be able to do that. So in the next video, I'm going to use the calculator, and we're going to look at the definition from the book. Now, let me emphasize this again. Permutation, order matters. Permutation, order matters. Okay? First place is different than second place is different from third place is different from fourth place, all right? If the order doesn't matter, then we're doing a combination, but we'll look at that one in a couple more vids.